The random variable y has binomial distribution where n is the trial and p is the probability of success. So both are unknown. So we have to use normal approximation. So the probability that y is at least 65 is 0.2266, and the probability that y is more than 52 is this. So let's start. Let's see how it goes about. So the first thing that we have to write is this is the distribution, and we have probability of y is, so they mentioned at least, that means greater than or equals to 65, and that is equals to 0.2266. This is one information given, and the other information that is given is that probability of y is more than 52, that means greater than 52, and that is 0.8944. So we put down the information that we have. Find the value of n and the value of p. Now the question is, what do we do over here? We don't know what n is. We don't know what p is. We just know that we have to use normal approximation. So let's follow what they tell us to do. So using normal distribution as an approximation, so we know we use the value of mu or expected value as np. So this is np, and we know the value of sigma squared as npq, which is 1 minus p. So we have a distribution. So let's define the normal distribution as x, since it has not been used over here. So mu is np and variance is np 1 minus p. So this is what we have. Now the first thing we do is, for finding the probability from discrete to continuous, we do continuity correction. So let's do for probability of x is, the first thing of continuity correction is make it equal to something. So it is already equal to something greater than or equal to 65, and the probability will always be the same. So now what we have to do for the continuity correction, we have to check on a number line. So 65 greater than or equal to, so the continuity correction would be 64.5. Remember, we have to do a 0.5 plus or minus correction. That's called continuity correction. So this is x is greater than, now equal to sign doesn't really matter because continuity correction has been done, 64.5, and this is equals to 0.2266. So we got this. Now the next thing to do would be z-score. Remember, when we do normal distribution, we have to convert the standard regular normal distribution to a standard normal distribution. So for z-score, so for z normally distributed 0, 1 squared, so we can write probability of z, instead of x I'm writing z, greater than 64.5 minus, now the mean is np, so this is going to be np divided by the standard deviation is going to be np 1 minus p square root. Oh boy, this is going to be a bit complicated. So np 1 minus p. So that's the standard deviation. This is what we get. Now this is equals to 0.2266. The first thing you have to do while finding the random variable, since that's what we have to do, we have to find the value of z, you have to draw the normal distribution. So let me draw the normal distribution over here. So let me continue over here. So the normal distribution would have a bell curve, and we know the standard normal distribution has 0. So we have to shade it from greater than z. When you shade greater than, you have to shade from the right hand side. So that's what you have to do. So let's start shading from the right hand side. And what we get over here is this, and the probability is 0.2266, that is 22%. So this portion has to be shaded. This portion is around 22.66%. So this is going to be plus a. So what we can write over here, let 64.5 minus np divided by square root of np 1 minus p equals to a. Therefore, probability of z is greater than a equals to 0.2266. Now we have to look up the table. Now there are two tables in the normal distribution. One is the percentage table and the other is the cumulative table. The percentage table is greater than. So let's see whether we can find the probability 0.2266 in the percentage table. Now here, this is greater than, z is greater than. So this is a special table, greater than table. And the probability is at first. And on the second column, we have the values of z. So 0.22 is nowhere over here. So let's move on to the regular cumulative table. And that is this one. So we are looking for a probability. Now here, the probability is in the second column and z is in the first column. So we're looking for a probability 0.2266. So 0.2266 is not here either. So what do we do? It's not in the other table and it's not here. The probability starts from 0.5. So what we can do is we can write it as, first of all, less than, because remember, this table is less than. So 1 minus probability of z is less than a equals to 0.2266. It turns out to be 1 minus 0.2266 equals to probability of z is less than a. Therefore, probability of z is less than a equals, let's bring out the calculator. So this is 1 minus 0.2266 and it is 0.7734. 0.7734. Let's go back to the table now. 0.7734 is now going to be on the table. So we have 0.7734 right over here. That means this one is the value of the probability and we're looking for z, 0.75. So we can write, therefore, a equals to 0.75. Since we know the value of a, we can plug it into the first equation and we can find some sort of an equation. So 64.5 minus np divided by square root of np1 minus p equals to 0.75. We have some sort of an equation. Let me keep it over here. This is equation 1. The next information, y is more than 52. So y is more than 52. This is what we're going to work on. So let's move over here. So here what we have is, for probability of x is greater than 52 and the probability is 0.8944. So the first step we have to do is continuity correction. Remember, we are doing normal approximation. So the continuity correction has to be done first of all with equal to. So greater than or equal to 53. Remember, binomial is discrete. So now we draw a number line over here. So if this is 53 greater than or equal to 53, so this should be 52.5. Therefore, probability of x is greater than 52.5 equals to 0.8944. So we have that. Now we have to do the z-score. Therefore, probability of z is greater than 52.5 minus np divided by square root of np1 minus p, and that is going to be equals to 0.8944. And we have to draw the diagram again. So let's draw the diagram. This is the normal bell curve. So this is 0. So greater than means we have to start shading from the right hand side. So if we start shading from here, and if we shade and keep shading, so this is half of it. This is 50%. We need more. We need almost 90%, 89 point something. So we stop over here. So this is 89.44%, 0.8944. So we can write this is minus b. So this is definitely negative because it is before 0. So what we can do over here is let 52.5 minus np divided by square root of np1 minus p equals to minus b. So we can write probability of z is greater than minus b equals to 0.8944, and we can reverse this and write z is less than b equals to 0.8944. Obviously we have to look up in the other table, the cumulative table. So 0.8944. Remember, we have to look up in the second column where the probability is given. So 0.8944 is going to be over here. 0.8944. So this is 0.8944 and the value of Z is 1.25. So we can write therefore B equals to 1.25. So when B equals to 1.25 and we plug the value of B in this equation, we can write, so 52.5 minus NP divided by square root of NP 1 minus P equals to minus 1.25, and this is equation 2. Now we have to solve this. The question is, how do we solve this? In order to solve this, what we have to do is we have to take this equation over here and we have to take the previous equation, equation 1 and equation 2, and somehow we have to find a connection. What we can do is we can write this equation equals to 64.5 minus NP divided by 0.75 equals to square root of NP 1 minus P. And here we can write 52.5 minus NP divided by minus 1.25 equals to square root of NP 1 minus P. So this is 1 and this is 2. So now this square root of NP 1 minus P is equals to square root of NP 1 minus P. We can equate this to. Hence, we can write 64.5 minus NP divided by 0.75 equals to 52.5 minus NP divided by minus 1.25. So what we can do, we can cross multiply. So if we multiply this to this side and 0.75 to the other side, this is what we get. Minus 1.25, 64.5 minus NP equals to 0.75, 52.5 minus NP. And let's use the calculator. So the first thing is minus 1.25 multiplied by 64.5 and we get minus 80.625. Minus 80.625, and this is minus minus plus 1.25 NP. Now the next thing that we have is 0.75 multiplied by 52.5, and that turns out to be 39.375. 39.375, and this is minus 0.75 NP. So we can find the value of NP from here. So what we can write is that, let's bring all the NP on one side. So 1.25 NP plus 0.75 NP equals to 39.375 plus 80.625, and that turns out to be, so we can get 1.25 plus 0.75, and that turns out to be 2 NP. That's pretty nice. I thought it would be very complicated. The next one is 39.375 plus 80.625, and that turns out to be 120. That's pretty nice. 120. So NP equals to 60. So we got the value of NP. So what we can do from here is we can put the value of NP in one of the equations. So we can find the value of P. So we can do putting NP so let's put this in equation 1. This is equation 1. So we can write 64.5 minus NP is 60 divided by 0.75 equals to square root of NP is 60. This is 1 minus P. So we can write 64.5 minus 60 is 4.5 divided by 0.75. So we get 4.5 divided by 0.75 and we get 6. So this is 6. If we send the square root to the other side, this becomes square. And this is 61 minus p. So that turns out to be 6 squared is 36. 36 divided by 60. So we get 36 divided by 60 and we get zero point 0.6. So this is 0.6 equals to 1 minus p. Therefore, p equals to 0 0.4. We got the value of p. P equals to 0 0.4. That's the probability of success. Now, we can find the value of n because np equals to 60. So, n into p, which is 0 0.4, equals to 60. Therefore, n equals to 60 divided by 0 0.4, and that turns out to be 60 divided by 0 0.4, and that is 150. So we got the value. So the answer is n equals to 150 and p equals to 0 0.4. Now, as you see, the calculation is quite complicated. It's very long, and it is easy to get lost in the middle of the sum because the complication of the steps of the calculation. So it might be a good idea to, instead of starting the sum the way we usually do from the binomial to the approximation, we could have done it like we do in S1. Instead of writing NP and NP1 minus P, we could have just written here mu and sigma squared. And we could have found mu and sigma squared just the way we do in S1, and then we could have written mu equals to NP and sigma squared equals to NP1 minus P and solved that equation. That might have been better. But of course, it all depends as you're taking the test, what method is easiest for you, and it might be simpler for you to follow the steps of approximation. So it depends what you prefer.